Example 2. We are modeling an annuity using a recurrence relationship, so the same thing, but this time we've got a bit of a table. So Spencer makes an initial deposit of $1,000 on an investment. Okay. So what we're trying to do here is we're still going to fit it in to that same formula. Vn plus 1 equals Vn outside of 1 plus R. And this one is plus D because it's an investment. So in other words, our value is going up rather than down. With the loan, it was a minus D because we were coming down. All right. So this one here is 7.2% per annum, but it's compounded quarterly. So we're going to have to do 7.2 divided by 4 to give us our quarterly one. We've got an initial deposit of $100 and an additional deposit. Sorry, I should say additional deposit, not initial. The initial one is $1,000. So let's have a look. Where are we starting with at the moment? So all the information is there. We're going to fill in this table, and then we're going to calculate the amount of interest. So let's have a look. So Vn, so if n plus 1 is 1, then we must be starting with V0. So it's the value, the initial value. So our initial value is going to be $1,000, and we got that from there. That's our initial deposit. Then our additional deposit that he's making, we get from here, which is $100. So that will be $100. Now that initial deposit is happening each quarter. So we know that that is going to be the same the whole way down. That is the deposit that he's making each quarter. This one here, when we've got the Vn plus 1, that's going to be V1. We don't know what that equals at the moment. And so this one here, you've got Vn, so that was 0, that will be V1, that will be V2, that will be V3. And this one will be V2, V3, and V4. So you can see how that pattern's emerging. Now, this value here is going to be the same as that value there. That's where it's going to come. We're going to calculate this value, and that's going to translate down into that point. And same with this one here. Once we do V2, it's going to translate down there, and we just shift it down, and that's where we start each time. But we haven't calculated V1 yet, which we will do in a second. The other thing we want to do is I want to go, okay, well, my D I know is 100. My V0 I've already written down, that's my starting value, is 1,000. One thing I need is my interest rate. I know it is 7.2% per annum, but I need it to be 7.2 divided by 4 to give me a per quarterly interest rate. So 7.2 divided by 4 will give me 1.8. So I'm using, should put that, 1.8% per quarter. It's really important that we remember that our interest rate and how often it's compounded have to be the same unit or time frame. So this is quarterly, so we had to divide that by 4. All right. So that's all we really need. We're now going to sub it into the formula. So we're going to have, for the first one, for the first quarter, so first, I'll just put quarter because I'm lazy, is going to be 1,000 times 1 plus 1.8% plus 100. So that's the VO, then the 1 plus the interest rate plus 100, and that will give me $1,118. So that's that. That is that value that goes up there, and that is also going to translate down there. Okay, now the second quarter, we start with the 1118. That's our new VN. Okay, so that's the one for the second quarter. That is the VN for the second quarter. So that VN changes each quarter because it takes the value of the N plus 1 from the previous. This, however, stays the same because it's our recurrence, plus 100. So that stays the same. That second bit stays the same. The only thing that's changed is the front number and then the end number. So this one, we will get, and once again, you use your answer button to do it, but we're going to get 1238.12. So 1,238 and 12 cents. So that will also transfer down to here. Now remember, use your answer button to keep the exact, because there's many decimal places in potentially. So the third quarter, we're going to have 1238.12 times our recurrence, which is 1 plus 1.8% plus 100. That is the recurrence. And when you do that, I should have approximately equal to on these two to be precise. That will give you 1360.41. 1360.41. 1360.41. So those two. And we're now onto the fourth quarter. Once again, use the answer button so that you're getting the exact values rather than the rounded off one. So 1360.41, 1 plus 1.8% plus 100, which is our recurrence. And that will give us an answer that is approximately equal to 1484.90. Let's chuck that in, 1484.90. So we've now filled out the table and we have done the 4 deposits. Okay. Like I said, later on, you're going to be using a table of values and it'll make it much easier. Now what we're going to do is we're going to work out the interest. So to do that, we know that the total that we have at the end of the 4 quarters is $1,484.90, but we need to only find out the interest. So we need to take off what the initial deposit was of $1,000. However, we also made additional deposits of $100 per quarter. So we did additionally deposit another $400. So if you do the 1,484.9 minus 1,000 minus 1,400, it will leave you with $84.90 in interest. And that is how that works. Hopefully that made lots of sense.